how do we measure time? Well, we measure time because while we have those things changing in us, there is also regular things outside. And those regular things, they leave traces that we can use to measure time. And so that's where it's a little bit funny to think that there could be internal representation of time or internal measurement of time. What would that mean? We don't know what it means, an internal measurement of time, because measurement by definition has to be somehow related to an external or observable standard. That's why I think people are interested in Bergson now, is because this durée is really something that is not in our computer or that is not in AI.
This is Brain Inspired, powered by The Transmitter. When you play hide and seek, as you do on a regular basis, I'm sure, and you count to 10 before shouting, "Ready or not, here I come," how do you keep track of time while you're counting? Is it a clock in your brain, as many neuroscientists assume, and therefore search for in their research? Or is it something else? Maybe the rhythm of your vocalization, as you say 1,000, 1,000. Even if you're silently counting, could it be that you're imagining the movements of speaking aloud and tracking those virtual actions? My guest today, neuroscientist David Robbe, sorry about my French, David Robbe, or Robbie. David believes that we don't rely on clocks in our brains or measure time internally, or really that we measure time at all. Rather, our estimation of time emerges through our interactions with the world around us and or the world within us as we behave. David is group leader of the Cortical Basal Ganglia Circuits and Behavior Lab at the Institute of Mediterranean Neurobiology. His perspective on how organisms measure time, or duration, is the result of his own behavioral experiments with rodents and by revisiting one of his favorite philosophers, Henri Bergson, the Americanized version. So in this episode, we discuss how all of this came about, how neuroscientists have long searched for brain activity that measures or keeps track of time in brain regions like the basal ganglia, which is the brain region that David focuses on in his research. How the rodents that he studies behave in surprising ways when he asks them to estimate time intervals or durations, and how Bergson introduced the world to the notion of durée, our lived experience and feeling of time. So this conversation is particularly fun for me in that I have a philosophical bent. I'm not a philosopher, but as a scientist, I often struggle, and do so aloud on this podcast, I struggle with how philosophy can influence, in a practical way, my own science and science more broadly. And so David's recent past is a good case study in that very phenomenon. Click below for the show notes where I link to the paper in which David really fleshes out everything that we discuss. That paper is called Lost in Time, Relocating the Perception of Duration Outside the Brain. If you value Brain Inspired, consider supporting it on Patreon to get full episodes, access the full archive of episodes, join our Discord community, or just express your appreciation. Thank you to all my patrons and to The Transmitter for their support and their community work in neuroscience at thetransmitter.org. Here's David. Pronounce your name for me so I get it right when I do the intro.
So in French, I would say David Robbe.
Robbe, okay.
Robbe. But
Robbe.
It's okay.
Okay.
Yeah. If you say Robbie, it's fine. Many people say Robbie, and that's fine too.
Okay. Yeah, and I'm probably going to say Henri Bergson instead of Henri Bergson. Yeah. Actually, all right, so I'm going to start here. We were just talking offline, and we'll come back to it about basal ganglia because that's a lot of what I'm doing these days, and that's what you do in your historically and in your day job, in your real job, perhaps. Yeah. Although what we're going to talk about maybe is coming a little bit more into that because they're related, essentially. So.
Oh yeah, totally. And this is where it got me started in the time business. Was all those kind of stories in the mid-90s saying that there were potentially internal clock in the striatum that were like providing internal representation of time. So that's what got me started. From the beginning, I had a problem with this idea. That's where things
from
started.
The beginning. Okay. All right. Well, let's get to that. But first, I want to say, because we were talking about what I'm doing, and I'm in Eric Ittrey's lab, I reached out to Eric and I was like, hey, what, anything you want me to ask? And first of all, he said, by the way, so I need to ask you, how's the tennis game, semi-pro? How's your tennis game coming along?
It's going a bit down. I have to admit that those last 2 years, I've been playing less. So I play less. I still do from time to time local competition in Marseille, and wow. I need to go back to that more seriously. But I have to admit that I kind of like I went a little bit down in my tennis, but it's still something that I enjoy a lot.
Sorry, this is a total aside already. I'm terrible at doing this, but did your sports and tennis in particular, perhaps, did that lead you to interest in behavior and or timing?
So I think it's interesting you asking that. I think at the end, so as a teenager, I was a lot into sports, tennis and football. I mean soccer, and yeah, I went in neuroscience, and it's interesting how I'm converging more and more back to behavior, and I think it has something related to my my passion for sport and movement. So it's interesting that I started by doing slice electrophysiology, then I went to do a postdoc in Henri's lab with in vivo in behavior recording, and now I'm doing less and less physiology and more behavior. So, but
why is that? Is that because for me, I've become more interested in behavior, and really what I'm interested in is, the connection between neural activity and behavior. Mm-hmm. But the more I learn, the more I know how little we know about even the neural side of it. And then I guess my framework for thinking about these things has changed, and behavior itself is an open question, and neural activity is an open question. So and of course, I'm just preaching to the modern neurobehavior choir that you have to study these things. We're embodied, and you have to study them in conjunction.
Yeah.
No,
I think it's a combination of things, but it's true that my experience has been that it's really important. I mean, like behavior can explain so many things just by itself in the way. When you do electrophysiology in vivo, so if your behavior changes, your neuron activities change. Okay, so that's the first thing I learned with Henri Bergson, and that was really great. And so I really enjoyed actually watching rats running in a maze and seeing actually how you could almost anticipate if one was going to do right or wrong just by looking at the way rats were running. So I got really into behavior, and then I read, and I had the chance to meet one of the regular guests from this podcast, John Krakauer, who really also pushed me and kept telling me, no, but that's actually, you have to be very careful with behavior. And also some personal experience, how it is easy to actually, when you do IFIs in behaving animal, it's so easy to basically have a sort of bias that is going to make you interpret the data the way you want to interpret them, because it's so I realized a couple of times in my career that I was very close to make mistakes, and then I thought, we need to it's the key is we need to understand really well what the animal is doing. Otherwise, we can tell basically almost whatever we want, especially when you record in a place like the striatum, in which you have a very heterogeneous kind of type of response. So that has been the trajectory on those years, really trying to understand well behavior. Also, practically, I mean, chronic electrophysiology in behaving mice is really, really hard if you want to do it right. And in France, it's tricky. We have very short, the funding is limited, the PhD duration is short. So it's tricky to have a project that really, that you manage to go through a PhD in which you do, good behavior, good electrophies, good data analysis is just impossible. So I ended up But I hope to do more electrophysiology soon again. But I ended up doing a lot of behavior, also because it's already a lot of work, and but you can make a story in like 3-4 years if you do good behavior and a bit of perturbation, I think.
Yeah, I was going to say, I mean, that's why we come in with, we have to be careful because we come in with, I guess the technical term would be bias, but we have a story about what we're looking for. And by God, we're going to find it or something related to it. Yeah,
exactly.
Who is Henri? I'm going to say Henri Bergson. Henri Bergson. You say the name again?
Henri Bergson.
There you go. I'm just going to butcher it the whole time. Who is this historical philosopher / scientist / mathematician, sort of, and why are you so obsessed with this person and his ideas?
Yeah, so he's not a scientist, huh? He's really a philosopher.
Yeah.
So he's a philosopher of, I think he's born in 1859 or something like this, and he died in 1941.
41, I think it's 41. Yeah.
So yes, he's a French philosopher that was actually extremely famous at some point. He wrote a couple of important books.
He was a celebrity in his day.
He was a celebrity. So he's right now he's a lot in the light. After being in the shadow for a while, he's been more recently a lot in the light. There's a recent biography in English that has been published by Emily Herring.
Oh, okay. But
Yeah,
is it? I just want to stop you because I can never tell these days, especially with the algorithms that feed you what you're sort of have been searching for, and just kind of you get in that silo. Is he kind of making a comeback in
I think
academics,
he is, yeah.
or is it just me that I'm seeing more of it?
No, he's making a comeback, but it's not just like since last year or 2 years ago. I think it's more like something, let's say, that are starting growing maybe 10, 15 years ago. And now it's starting to really. So first he was like more something local, also evidently a lot in France. But now I think it's becoming bigger. And my idea is because I think you could define him as really a philosopher of the living. All right. Okay. It was really about understanding the difference between, what's so special about living organism versus, other non-living things or the movement of non-living things. So that was his big things, and he tackled this question at different level. The level of the perception of time, then of memory, and then evolution. His big famous book is Creative Evolution, 1907, for which he got the Nobel Prize of Literature, which is a paper that has a book that has. He's been very misunderstood, Bergson, because he's a philosopher that tends to say, there is some limits to science, and so scientists didn't like so much this idea. So he went, he's famous also for a famous debate with Einstein, but so he challenged some of the ideas of Darwin in terms of the mechanism behind evolution. He was a true believer in evolution, but he was not sure about the mechanism that allows species to evolve. And because he had this kind of view that was not mechanistic, he got kind of like, he got some like strong pushback when all the genetics movement came strong in the middle of the century. And so it got a little bit, kind of push aside. Also, he had a very special way of doing philosophy. He didn't really build a school. So it got quickly forgotten. But the truth is that if you read his book, it's really deep. So I think what is nice is to see how somebody at some moment can be kind of like forgotten and then come back and sound so modern. When you read Bergson, that's really what strikes me is how in so many instances, it's like he's just talking about the stuff we're dealing now. So that's really cool.
Why is that? That is always the case. Like sometimes I think that an academic's job, it seems, whatever history, philosophy, science, is just to point out who had that idea beforehand. Because it's all, like Bujaki says, there's nothing new under the sun. It's all of these ideas, right, have been well traversed by sometimes forgotten people.
Yeah, it's true. It's true. but yeah. But I'm sometimes, so I have debates with some friends. I feel like Bergson did something very new, but it's difficult because he was building. Now that I'm starting digging a little bit more, and I get some help from some philosopher friends, I realize that he himself also was influenced by even lesser known people. So it's very interesting to see this dynamic.
Yeah, the other comment I was going to make is I was recently at a gathering at Carnegie Mellon University in Pitt for someone who was a mentor of mine and many of us who just recently passed. And I asked the question at our little gathering, like, so the thing is, he did very careful, super sharp guy, very careful science, wasn't concerned with glossy journals, just concerned mostly like with just asking the right questions, pursuing it the right way. And, he's got a great publication record. And I asked, like, what do you think his legacy is going to be? And it's an interesting thing. What I kind of imagine is 40 years from now, people are going to look back on some of these papers, right, and dig them up again. And in the meantime, he might be kind of forgotten. It's hard to tell. But
yeah, maybe also the people that he talked to will actually, he will probably have affected the life of a significant amount of people that are going to do science in a different way because of working with him. So I think even like Bergson, even when he was kind of like forgotten, he was still very influential, but just people didn't want to mention his name because he was persona non grata, but he was still very influencing people. So that's why I think,
Well, from what I understand too, that he is maybe at least popularly most well known for losing that famous debate with Einstein. But then a lot of careful historians have looked back and it's a lot more nuanced. He didn't just lose a debate. They misunderstood each other. They called each other out in their misunderstandings. And so it's not clear who, quote unquote, won or lost.
Clearly he was perceived as the loser. I mean, he was tough not to lose against Einstein, no? I mean, I remember myself, when I was a student, I had a poster of Einstein in my room in the university. I had no clue and no understanding about the theory of relativity.
Of course not. He's just a figure, an idol. Right?
So there was something so big about him. Nobody could really win against this guy. But it's true, you're right. Like a couple of people have done some work. Jimena Canales, I think, is the one that wrote this book, the philosopher and the
scientist and the philosopher and scientist.
Yeah, exactly.
I think that's right.
So in which she shows that there was actually no real debate. They misunderstood you said it right. Another French philosopher is doing I think there's a book that is going to come out soon about it, Élie During. Yeah, I think actually, so I would side with Bergson in the sense that, so you have to read, so he wrote a book.
Wait, but you should say what the debate was about, what you're going to side, yeah.
Yeah, no, the debate was that, so a sort of like implication of the theory of relativity was that maybe there would be some kind of like multiple temporality. There was no more this unitary Newtonian time was basically gone, and Bergson said, well, your finding is basically about things that move extremely fast, very close to the speed of light, but we can still wonder if, in terms of like our experience of time, if we should completely challenge this idea that we, more or less, all of us, you and me right now, are living on the same tempo. Okay, so that was the debate. And what's kind of impressive is like, so he wrote a book about it, which was called Durée and Simultaneity, so duration and simultaneity. And if you open the book, the beginning of the book is him actually rewriting the equation of the theory of relativity, and saying that he entirely agrees with the theory. So he was a guy that was able to actually redo the math, which me, I'm not able. People say it's not that complicated, but he did this effort. So he did a huge effort, and actually he called himself that is more Einsteinian than Einstein. But his question was, can we make conclusion about our experience of time based on a theory that is applied to things that move at the speed of light, or very near the speed of light? And that was his question. And to the discredit of Einstein did not make a lot of effort. If you would kind of balance the two, if one guy had made a lot of effort to understand the theory, it was more. But the problem is that Bergson is not always easy to understand. So his weakness is that he didn't manage to make himself understood to Einstein, and Einstein was not very patient.
So he also, Bergson, people back in the day, and this is the story that is kind of now becoming overturned, is that, well, he wasn't good at understanding the science, but he actually was good at understing the science. Everything that you
he
said.
Was good. He was very good. He was an extremely bright guy. He had lots of prizes in mathematics when he was 18, 19, 20, and his teacher were extremely disappointed that he decided to do philosophy. They were like, "Come on, you should be a bright mathematician, and you're gonna end up just like a philosopher." There's like a say like this that goes in the legend of Henri Bergson.
Oh, poor philosophy. Why does it have such a bad rap? Because I was gonna ask how you got wrapped up in all of this, because I have a philosophical bent, and then there's something behind me always saying like, "Oh, you should stick to the science. People, they're all gonna make fun of you, but don't waste your breath on philosophy." Yeah.
Well, so I think I always liked philosophy. So even if I'm not sure I was really good at it, and I was very interested, like almost everyone that does neuroscience is interested in, the relationship between mind and body. And
which was philosophy for a long, long time and still is. Yeah.
Yeah. But I was studying biology and I was starting to study neuroscience, and I felt like neuroscience was really the key to, as a student, I was like, okay, neuroscience is explaining all this great. And one day I was in a library and I saw, really by chance, I saw a book of Bergson, which is called Matter and Memory. And the subtitle of the book is an essay about the relationship between l'esprit et la matière, so the spirit and the mind and the matter, or in the body, something like this. And I was like, oh wow, this is exactly what I'm trying to understand with this neuroscience stuff. So I took the book and I started reading it, and it was kind of a shock. Like I didn't understand anything that guy was saying. He was basically saying on every topic the opposite that what I was thinking. But with you could see that the guy had thought a lot about it, and he was very confident. And he was like, "It's impossible that the brain is an organ that generates representation." And I was like, "What? What are you talking about?" Or it doesn't make any sense to think that the brain stores memory. And I was like, what? The guy is totally nuts. But so I didn't go through the entire book, but I got one thing at that time, which is in the first chapter of this book, is that perception is a beginning of action. So that's the first part of that book. And I found that even if it took me a long time to understand this idea, at the end I was like, yes, it's true. We only perceive things we're going to be able to act on. That's not a bad point. So he had this loop, the fact that, we're not information processing machine, but we are constantly, what we see around us is basically already kind of like adapted to our motor system. So a perception is basically a question asked to my motor system. And I found this idea very nice. The rest of the book, I couldn't deal with it.
Yeah,
it was too hard.
This is pre-ecological psychology, right? Gibsonian.
Yes, this is pre-ecological psychology, which is something that then got me into ecological psychology later on. And I was like, but how come they never cite Bergson? I was very surprised.
I was about to ask you
why.
That. Yeah.
Why is that? It's very surprising.
You can, yeah. I mean, there are trails.
Because Bergson was, I think, labeled with this idea of élan vital, which came later.
Yes.
He was labeled as some kind of like esoteric, kind of like romantic guy.
What is élan vital for the listeners?
So the élan vital is a sort of metaphor that Bergson brings in his third book, which is Creative Evolution. And it's not, you really have to understand it as a metaphor. It's the idea that he's trying to think. So he's basically persuaded that that there's something different between living and non-living matter. And that should be some kind of original impulse. He's not believing in some kind of like fluid, so he's not a vitalist. Okay?
Right, which is that's what it got labeled as, is there's some sort of magic
but
fairy
he's not.
dust. Yeah.
He's not. He's a scientist. He believes that the body is driven by, electricity, chemistry, etc. But that at the beginning of life, there is some kind of like impetus, that is like sort of force that is pushing living to thrive and survive and also transform itself, etc. And this
create, transform itself and create
against matter. Okay, that's the big thing. It's a form of creation, while matter is kind of like, it's kind of like trying to kind of like kill you or like oppress you.
Yeah, going against entropy, despite matter, you're able to create.
Exactly. So he had this metaphor of élan vital, and that got him kind of like smashed by scientists. Also, other philosopher Bertrand Russell was really against him. So that's a bit the story. So,
okay.
But yeah, so that got me into Bergson. And then I kind of like, I was reading from time to time article of him, but I never actually at that moment, I never understood the concept of durée.
So that's what you're onto with this paper that we're going to frame our discussion around.
Yeah.
And so when did you pick up the concept of durée? Was it after your neuroscience beginnings? And
yeah. So that was way after. So actually what happened is that, so we were interested in the lab. So there was a lot of those hypotheses saying that there were like kind of like really time representation in the striatum.
Yeah.
But everybody knows also that the striatum is really important in motor control. So I had this idea, and others too, that probably if the striatum had a role in like time estimation, it was because it had a role in motor control.
Well, and we should say like this idea of there being time represented internally, it's been applied to many parts of the brain. It can be decoded from many parts of the brain. And so it's an odd, so it's been ascribed to, so the assumption is we must have this, because we're good at timing things, we must have these internal clocks that our brain produces that we can then read out as organisms to do things, right?
Exactly. But at the time where I started working on this, the striatum was one of like the big kind of there were striatum and prefrontal cortex and cerebellum were kind of like the three kind of like hotspot for time clocks at different time scale.
Yeah.
So we wanted to, so my idea was that actually the role of the striatum in timing was related to movement, and that it's because it changed animal move that animal changed their performance in time estimation tasks. So with actually my first postdoc, we designed this crazy experiment. Pavel Rueda Orozco, who's now in Mexico, we designed a task on a treadmill. So we knew another thing that everybody knows, but nobody speaks too much, is that if you do a time estimation task with like in which you request the animal to really respect a time interval, otherwise he will get like no reward or a punishment, then animals develop those kind of like weird superstitious behavior. So this was something that was known. Okay, and this was the problem that we had also, is that we know that the striatum responds to movement, to sensory stimuli. So the trick is that how do you make an experiment in which you can dissociate time and movement and sensory response, knowing that on top of that, the animals are going to tend to develop some kind of motor routine, superstitious behavior. So we decided to do a time estimation while rats would be running on a treadmill. Okay, the idea would be to kind of clamp the animal into a state in which it cannot really escape. And what we wanted to do is that we wanted to change the speed of the treadmill. And our expectation would be that if the treadmill goes faster, maybe the animal counts with his paw, and so then he would have the impression that time is passing faster, something like this. This was kind of our intuition. Okay. And then we got this very weird behavior. So the task was, we had a treadmill, and the animal had to go at the front of the treadmill. There was like a reward area that was clearly salient. And the task was the animal has to go there 7 seconds after the trial started and the treadmill start pushing the animal away from this reward area.
So if the animal is still, it starts moving back on the treadmill, but what you guys thought was that it would just kind of keep running right next to the reward port and just time it for 7 seconds. Yeah,
exactly. And they didn't do that. They all the rats starting doing this strategy in which first they struggled, okay, because they would go too early. Okay, they would go too early. So they would go too early, get like, beep, a sound. Then we had like a sort of we had the rat run for an extra time. So they did a lot of error trials because the impulse of a rat, like us, is if he's thirsty and there's a reward in front of him, he goes there straight. Okay.
Yeah.
So he does that over and over until he gets bored. And then a new trial starts. The treadmill pushes the animal away, and then at the end, the animal bump into the rear wall and then run, and then he gets the reward. Because now 7 seconds, so we had a time of 7 seconds. 7 seconds has elapsed, and he gets the reward. So that the animal understand that to get the reward, they have to go to the back, and then
that's what their superstition understands. Yeah,
exactly. So we were really disappointed because this is not what we wanted, and we tried a bunch of stuff, and it never worked. But we said, okay, this is great. We have a nice stereotype behavior. We can do recording in the striatum, which is supposed to be important in stereotype behavior. And we did still a very nice paper on this with Pavel. But then we had the visit of John in the lab, and John told us, you guys need to understand better this task, what the animal is doing, etc. So we did a lot of experiments. And we realized that really the animals were unable to do this task if they were not allowed to use what we call a motor routine.
Yeah, okay. But did they all develop slightly different routines, or was it?
So in our case, like 80% of the rats developed this routine, but I think it's because of the setup. Mm-hmm. We had some rats that were doing other stuff, but they were still doing some stereotype stuff.
Yeah, still stereotyped, but it wasn't always just hit the back wall and then go.
And run. But this is the easiest one.
Yeah.
Basically. Yeah. So I think this is why many rats stumble onto this one.
Wait, let me just pause here and just say, because this experimental setup is sort of in between the hyper-reduced experimental setup that had become dominant in neuroscience and was still, that's my PhD work, was fix everything as still as possible. The organism needs to move only its eyes, right, to perform this task. And of course, the animal wasn't completely still. Of course, they were moving their arm, even if their head was fixed or whatever. And so they still, your point in the paper also is that all of these hyper-reduced experiments, the animal, people don't control for these little movement routines that the animal could be undergoing to help time behaviors in these timing tasks, for example. But so yours is in between. So that's the hyper-reduced. And now we have like these super freely behaving, and I guess those rats were freely behaving on the treadmill.
Yeah, it was freely moving. Yeah.
But they're still in the behavioral, like they're in an apparatus, right? That they're behaving
exactly
within that context.
And our idea was to somehow try to clamp this motor activity, and we failed because
clamp it while they're behaving freely.
Exactly. Yeah. And so we did a kind of a nice purely behavioral study in which we did a bunch of manipulation to see that, it was really the routine that the animal had no clue really about time. They really managed to do this task by developing a motor sequence. And if you perturb this motor sequence, then the accuracy goes down. And we were wondering, and some people told, we had the debate, why is this way? Or is there other condition in which the animal could do a time estimation task? Is this just like a failure to basically be understood by the animal, etc.? And this is where I stumbled again by chance on Bergson. Actually, it was just at the beginning of the COVID.
When you're going through your old books and saying, "What shall I do now?"
So no, actually, more luckily, there was a podcast in France about matter and memory. And so there is this really cool philosophy podcast that not exist anymore, called The Chemin de la Philosophie, The Road of the Philosophy. and they had a podcast in 4 episodes, the 4th chapter of Matter and Memory. And so I'm like, okay, I have time now. I'm going to listen to that. And the first podcast, the speaker is like one of the most famous scholar of Bergson in France. Frédéric Worms is his name. And he says, well, we have to understand that the Matter and Memory, the book, is the problem comes from actually the first book of Bergson, which is Time and Free Will in English. And in that book, Bergson says that we misunderstand time because instead of living it, we spatialize it. And then what was very interesting for me is that the conclusion of our paper, so a paper that we published in PNAS in 2020, was that rats were developing a spatial routine to be proficient into a time estimation task. So that was like the conclusion, that they were spatializing time. And I was like, what? Like, it's exactly what our rats are doing.
Wait, you wrote this before you came across the...
Nice. The 2020 paper was written, I hadn't been back to Bergson. And then I was like, oh, I need to read this first book. And then it was really kind of a sort of like a sort of deep eureka kind of moment.
That is the best when you revisit, although you weren't revisiting in this case, but you were revisiting Bergson, but you weren't revisiting. But my point is, when you read something, even that you've read before, but you're coming at it from a different framework, you get all of a sudden it expands and you have this eureka moment. It's so beautiful.
Yeah, it was like, wow, but yeah, he's explaining us exactly why animals do that and why they actually can't do a time estimation task. And so that was like, I felt very like...
Right, they can.
They can't do it internally. And actually what they're doing is just they're getting rewards. They're not really measuring time. They're just doing what we want us to do, which is getting reward.
Where your utility comes in, that they're actually basing their
that came a little bit later, but also with a bit thanks to Bergson, but because he has some idea about time being like a sort of cost. And actually there is a huge field in neuroscience about this idea about time being seen as a cost. So yes, this was my moment in which and it was great because this was the COVID lockdown. So I read this book, then I understood better Matter and Memory. So I read Matter and Memory, so I basically read like in circle, these 3 main books. And then I decided to write this kind of like long piece. And it was great. It was fun.
So with his concepts, then you were able to sort of reinterpret your own data, your own studies. And I don't want to lose the listener because you should talk about what durée is in Bergsonian terms, right?
Yeah. So the idea of durée is simply that when we experience time, when we live, because we have memory, our memory constantly prolong the past into the present. Okay, that's the way that we manage to have a conversation together. Is that we constantly remembering a little bit of the past into the present. Okay.
So every present moment is inundated with at least some of our past memories.
Exactly.
The entirety of our past, but maybe subjectively some of our memories. Yeah. So every given moment is created anew and is unique in that sense.
Exactly. So his point is that this thing is really, it's a sort of continuous, heterogeneous new thing that is created at every moment. So it's indivisible. You cannot divide it. You can divide it artificially, but the durée, the experience,
time itself is
that experience, it doesn't make any sense to divide. Or the example I like to use is when you grow impatient. Think about whatever occasion in which you grow impatient. It's something that accumulates, but you cannot really tell at which moment you are impatient. It's just it's a process. It grows. And you cannot switch, time. To be very impatient and mad and ready to yell at somebody, you needed to go through the process of waiting, but you cannot go from mad to super
Some people can. So some people, some very special people seem to be able to, but I take your point. But how is that related then to, how is that concept then related to externalizing time? And how do you,
So his point is that, so this experience, so basically experiencing time, being in time, because you cannot divide it, you cannot measure it directly. So then how do we measure time? Well, we measure time because while we have those things changing in us, there is also regular things outside. And those regular things, they leave traces that we can use to measure time. So for instance, the movement of a clock while I'm talking, it's moving, then it arrives there, and then the distance traveled from the moment I started talking or moving to the end, that gives me a proxy from time. So actually, measure time is not about time, it's about space. So that's his big kind of like discovery, is to say, hey, there is two aspects of time. One that is lived, in which because of memory, it's a sort of continuous melting pot of the past of the present, and you cannot be divided. You cannot measure it because one moment it's here, and then after that it's gone. So there's no possibility of measurement because measurement is about superposition. But
in that case, isn't there no time because it's always just present?
So it's not exactly just present because you remember.
Yeah, but that's part of the present, right? So it kind of hinges on your present subjective.
But it's growing in you. Otherwise you wouldn't become impatient. Something has to stay and accumulate for you to become impatient.
So it's ever changing. That's how you measure it, is because it's ever changing in the present moment.
But it's ever changing with this communication of the past into the present. I think that's really the key. Some people like mistake the philosophy, the durée of Bergson, with the say of Heraclitus that says, everything is changing. You never step twice. That's not the same idea.
I'll say Heraclitus for our American audience.
Yeah, sorry.
That's okay. Just want to make sure.
Yeah, exactly. So that's not the same idea, because for Heraclitus, it's continuous change all the time, but there is no memory kind of like effect, you see? And that's the key thing of Bergson. He's saying that each new moment is totally new. It's not just different, it cannot repeat. In the sense of like, Heraclitus is more like a sort of eternalist kind of philosophy. It's changing all the time, but it's kind of the same in the change. While for Bergson, it's actually new. It's really new. Something right now we're different. You can't measure it. It's not something like, so this, you cannot measure it directly.
I love this idea because, as a scientist, and you become a reductionist, and then you view everything in those terms, and then you think, wow, how does anything move? How is anything new? And I love this account of everything is always new, and it is an act of creation.
Exactly,
which is a wonderful thing. Yeah.
Yeah. So the point is that you need to be able to measure. You need to somehow relate to something external that you can leave fixed traces. So that's why movement is a good very change. The change of light is a good cue for knowing how much time is passing, etc. And this is why we keep saying all the time, "Oh, this movie was too long," or "The time passed too quickly." It's always
time. Yeah.
And so we have no way to actually not measure time in reference to space and movement. And so that's where it's a little bit funny to think that there could be internal representation of time or internal measurement of time. What would that mean? We don't know what it means, an internal measurement of time, because measurement by definition has to be somehow related to an external or observable standard.
It's a relational relation. You have to measure it. Yeah. So in other words, you have to read it out. But people like Dean Buonamano, who was on my podcast a long time ago, and lots of other people, are just continue to try to find this internal representation of time, be it in the recurrent dynamics of recurrent neural networks, be it in the timing of nested oscillations in the brain where you could read these things out. Accumulation models, all sorts of ways that you could represent time internally.
So you can use them to represent time for you. So you plot your firing rate changes, and then it gives you a representation of time because it's a change. But it doesn't mean that the animal use it as a representation of time. Like this was the point in which I agree with actually Henri Bergson had like a very similar idea that it's not because you have like a change in your brain and then you relate it to something that it means that this is a correlate of this thing. So it doesn't have to be that way.
Since you mentioned Henri and you did a postdoc with him, like in your paper, I'll just go ahead and ask this now, even though it's a bit of an aside. There's like just one or two lines, and they almost seem like extra thrown in, where you say, well, this is where Bergson got it wrong in his inside-out view. And this comes at the end of the paper, right? So you've built up all these ideas, and then it's like you're reflecting a little bit. And at the time, I didn't know that you had been a postdoc in his lab when I read the paper.
Yeah. So first I want to say that I'm a huge fan of Henri. Yeah? It's like, it was the best time of my life in his lab. Really, he's fantastic. Fantastic person, human person, and a fantastic scientist. Well, Henri has his view, very like, internal model. And
I'll summarize Henri's view real quick. The inside-out approach, right, is the very, very shortened version is that he thinks that we've gotten it wrong we have these like really old psychological terms that were invented by psychologists to describe what we were doing. And then we've been looking for neural activity and processes to map onto those terms and concepts. And what he proposes is instead, let's look at the way the brain is actually processing signals, information, the capacities, the structures, etc., what the brain is doing, and then use those to build up our psychological constructs, throw away the old psychological terms, maybe come up with new ones or understand them in a different way. And so that's his quote unquote inside out approach, saying that we haven't gotten very far with this outside in approach. So I just wanted to make sure we explain what his view was.
Yeah, no, you explained that's exactly right. And that's exactly the point. So the point in which I kind of like disagree with him, I think it's a false problem to say that the psychological terms are kind of like old fashioned and they don't reflect anything right. I think again, so if you think about an experience of time, so I'll take an analogy to try to convey what I want to say. You went to a movie, you had a great time, you were very entertained, and then, the movie finishes, you realize it lasted 2 hours and a half, and you say, you didn't see the time passing. Mm-hmm. Okay. So this is when you say you didn't see time passing, it's a very approximate description of what you experienced during the movie, but it's good for communication purpose. Okay. That allows to convey to your friend, wife, partner that you enjoy the movie and that you didn't see time passing. And so that's it. It's like, it's a short, it's an approximate label for the entire experience.
Yeah, it's a condensed, abstract version of what you went through.
Exactly, but you already lost a lot of information there. But there's no way you're gonna be able to recreate all this information, even with like if you had like recordings, all your brain activity during the entire movie.
Right. You wouldn't say at this point it was fanning in and fanning out from my retina through the thalamus, and then it really fanned in, and then there was a lot of gain from the basal ganglia. So yeah, you wouldn't go through all the brain activity.
Yeah. So the point I'm just making is that, we're never going to be able to explain some aspect of our psychology because we're always limited by, let's say, language. And that's fine that language is inaccurate because that's not the purpose. The purpose is not it to be perfectly accurate. It's just, it allows just to communicate enough. And so I think it's kind of a lost cause to try to find like the perfect description of like whatever brain cognitive stuff is going on in your brain with neuronal activity. Because anyway, and that, I think at the end, this was the point, because you invited John to ask question, no?
I think John asked a question. It was Henri and David Popple on the.
I think, or maybe David asked that question, or John, or whatever. One of them asked Henri, but okay, now you're going to have like you're still going to need at some point a word to describe
Right.
the thing that relates to your to this neuronal activity that you found was important. And so then you're basically, and it's still going to be, there's still going to be a gap. So you can't really, you can't just bank everything on the inside. There's always going to be an inside and an outside. I think that's the way I understood it.
Yeah. I mean, I get behind that, but I've become a radical pluralist, man. Like so it's not about the word itself. It's about refining the concepts that the word is attached to and stands in for, right? And so Yuri's point, I don't want to speak for him, is that the folk psychological terms that we use are attached. The way we understand them might be highly inaccurate relative to the actual processes going on. So it's not about whether you have a word or don't. It's just about refining the concepts. But I don't know if he would say that at all.
Yeah. So my point would be that whatever concept will come out will always be somehow insufficient for two reasons, because this is just something that is fixed. It's going to be a fixed label. Yeah. Okay. And our brain state is constantly changing all the time. So there will always be a kind of like a distance between the two, and that's fine. It doesn't mean that they're not related. It doesn't mean that science doesn't do a good job at approximating, attention, depression, feeling warm, cold, or impatient, etc. So it doesn't mean that science cannot do stuff on that, but there's always going to be a sort of like a little gap, and I think it's a good news.
But it's weird, like so neuroscientists do this all the time. We'll take and I'm sorry, I want to come back to the main topic here, but so using a term like in decision-making sciences, right? And in neuroeconomics, which you are right about and study, there's a term, let's say you're making a decision and then you use the term urgency, right? Mm-hmm. But then you define it sort of neuronally. You have an operational definition. Well, actually, sometimes you don't. So for urgency, then you ask, well, what would urgency look like in neuronal signals? So the other way to do it is to say, here's a neuronal signal. What concept could we, ascribe to that neuronal signal? And then it's something like, kind of like what we think of as urgency. So it's coming from the bottom up. I don't want to, anyway. Yeah. But
you could also try to define it behaviorally.
Sure.
And then manipulate urgency, even if it's, it's not a perfect term, but if once you decide what is urgency, which I think, you can, operationalize the definition, manipulate the parameters and see if it correlates with something more or less in the brain. And then I think that's
as long as you attach it with that operational definition, because what happens is that then just the term urgency starts getting used to not be attached to the operational definition, but with our common conception of urgency, right? And all the subjective baggage that comes with it.
Yeah, and the issue would also be that you would reduce urgency to the neuronal activity, which there is no reason to do that, because if if your definition of urgency is about a certain type of behavioral attitude in certain circumstances, then it's really, urgency is this whole complex thing. It doesn't have to be.
It's not that the neurons aren't feeling urgency.
Exactly. Yeah. I think the big issue comes with when you want to really localize things in the brain, like, if you want to say memory, procedural memory is in the striatum, whatever other form of memory, emotional memory is in the amygdala, then you get in all kind of trouble. And I think it's also a bit in reaction to this kind of like reductionism that Yuri also,
right.
Right. I'm not sure it's right to start from the brain. I think there is no reason to do that. I think we can do both.
I think you hit the nail on the hammer on the nail with the both. And I think it's so healthy to have someone like Yuri and have people like David Popel and John Krakauer, everyone saying they've got it wrong when everyone's right. And it's both and it's all right in some sense. But bring us back to, the reason that you felt, not the reason you felt obliged to, but what you were keying in on when you mentioned Yuri's inside out view with respect to the conception of durée and the way that you think of time related to brains and bodies and movements.
So why did I bring him in the?
Yeah, what was it? What is it specifically about that approach? I think you mentioned it earlier, but maybe just restate it and elaborate.
It's just that basically the point of Bergson is to really realize that our mental state, our life is constantly we're beings in becoming. Okay, we're constantly transforming ourselves. So having some kind of fixed label is great. You know, I'm called David, you're called Paul. Okay, and that's very convenient. It's fixed label. Also, we are constantly changing, and I think there is nothing wrong on that. And so, what I was kind of like calling into question is that, yeah, it's not a big deal that we use fixed label as long as we are aware that they are just labels. But the problem is that if we think that those labels are become like real things that we can find like traces in the brain, then that doesn't make any sense. I don't know if I'm clear.
Yep.
But
yep.
It's like, okay, now if you think attention is one thing, you're going to want to find attention in the brain. And that's ridiculous because attention is a dynamical process. So it's not going to be a thing that you're going to find in the brain. But it's good to name something attention for communication purpose, such as we know what we're talking about. But of course, it's a label. There's always a gap, especially in psychology. There's always going to be a gap between the labels that we use to speak, to communicate about science, and actually the real stuff going on, which is constantly changing. Attention is like a dynamical thing.
Why are humans, myself very much included, so prone to make that leap and say, oh, attention, it's a thing, and therefore it's in the brain, and I'm going to find attention in the brain? Why does that feel like such a natural way to think? And it's embarrassing how easy it is to do that.
Yeah, but I think the case of time is really it's very easy to speak about this kind of like tendency we have, because so we have this feeling of change of this experience of time, and we speak a lot about it all the time, and we say time went by quickly, slowly, a movie is too long, a trip is too short, whatever. So we constantly have those fixed label that we need to use on top of our experience that is constantly changing. And so at the end, we end up confusing the two. We end up basically having the feeling that we can divide what's going on in our brain. Because, if we take a clock, we see the clock moving and we have the feeling that it divides our life. And so we tend to, we get confused. I think at the end, because of language, we get confused. But then we feel things from the inside. And so we said, okay, there is something going on inside. And so why am I sometimes feeling time passing fast and sometimes passing slow? So then it's obvious that we want to attribute that to our brain. So we localize something that is dynamic first through the language. And then because we feel something inside of us is changing, then we think, okay, well, we need to explain it with like neuron. I think that's, it's quite straightforward. And it's typically what you see in paper about time. A paper about time perception in neuroscience starts by a sentence saying, time passes fast when we are fun and slowly when we're bored.
But then it says the neural mechanisms underlying this sensation are poorly understood.
Exactly, because the only explanation, because it's this kind of like subjective things, you feel like then it has to become from your brain. But the problem is that you attributed fast and slow to which are something that are about actually movement, to something that was very actually not movement. It was a temporal thing. It was like your experience, your memory, etc. So you see, I think it makes sense that you think that it becomes, it's something that is related to your brain activity, and in a sense, it is.
It is. It has to be. Yeah.
It has to be.
So make that connection for us then. So you have rats. You have this task where they're on a treadmill and they have to do these timing experiments, and they develop these stereotyped motor sequences to basically to help them keep track of when to go back to the port, when 7 seconds in one case has elapsed, so that they can get back to the port right just after 7 seconds to maximize their reward. So they go through these stereotyped behaviors between trials to do that. And areas like the basal ganglia are doing things that are coordinating their, and maybe this is where, of course, it's also in the brain, because you're actuating these movements through this continuous perception action cycle, but it's the movements themselves that get honed over time and that you use to as your clock. You're kind of using your own movements as a clock.
Exactly. So, but the kind of like tricky stuff here that's very kind of like subtle is that we're always tempted to say animal use their body and their movement to measure time, but they're not really aware that they have to measure time.
And yeah,
so they're So I think the key here is to think that we humans have this ability to feel time. Okay, the fact that if I stop talking now, something uncomfortable is going to grow, and we're going to say, okay, what's going on? Okay, so we're able to do that, and at the same time we're able to watch a clock move and kind of like relate our experience of change, or internal experience of change, with this regular movement. Okay, and that's allow us to kind of like measure and have like But the question is that do the animals are able to do that? Are they able to do this comparison? No, I don't think so. I think rats, they are really just in time. They're not comparing. Yeah. They're in time. They're not comparing with like something and saying, no, they're just in time. And so they cannot measure. They're just like, look, they're just like, okay, I gotta get my reward. And so they cannot like step back from time and compare what they've done with something regular. So they're just living time. That's why they can do those tasks. And that's why you can do whatever you want so that's my bet.
So humans again are special in this particular way, that they can reflect on their experienced living time with some machines ticking.
Exactly. Well, first was the sun, the rotation of the Earth. That's how it started, and then they developed tools to do that very accurately. But yeah, it's exactly that. I think there is something special in the ability of human cognition to be able to co-register their own internal change with external change. And I don't think I don't think rats are able to do it. That, who knows, maybe there could be some condition in which they could do it. Primates might be able to do it in certain conditions, but I don't think they can do it. And the key thing is that we do that, because we kind of like relax, or I don't know. But imagine a rat's actually thirsty and wanting to get reward. He's going to be in time a lot,
To your point, I mean, we are embodied, and reading your paper, I sat quietly, tried to sit very still and just, time something in my head, just match the seconds, right? But of course, I found myself barely nodding my head or vocalizing, like internally vocalizing the seconds, and so it's always related to some sort of movement, even if that movement, here's what I want to ask you, even if that movement is just on internal models or representations, like even if it's, do you think of cognition as internalized movement? This is terrible because we're using language and we were just talking about how, yeah.
It's great that you're saying that, because I'm trying to write a kind of like new shorter paper on that subject, and it's really about exactly that. It's like that cognition is a form of like, I mean, it's really close to, movement and a form of internalized movement, but can it be entirely internalized? That's the tricky question. As you've said, when you have to time in your head, it's very, you're like making those small moves. That recently I participated to online experiment on time perception, and the instruction were, so you're going to see a square and you have to say how long did the square appear, but you should not count. You should not nod. Right. What was it? You shouldn't use round numbers. There's all kind of like weird instruction. And I was like, I was thinking about, no, but what they should say that you should stop breathing. You should stop blinking. You should. Right. So it's an impossible experiment. And when you have an impossible experiment, maybe this should give you a hint that something is wrong. And I think that's the same with the rats. If you see that you have to, like struggle so much to have a rat learn something, is maybe the question is not the right question. And I'm saying that being a guy that has actually, trained and design experiments to do that. And now I'm not doing this anymore, and I'm quite happy. I'm doing other, and I feel, and time is still a very important thing, but you don't need to put it into this setup of measurement. I think that's not a good, and actually John was one, even I think he disagreed with many things I say.
No.
He said yes, because he doesn't like when you go too much into cognition and movement. He has this.
I know. I know. Yeah.
But he said to me, David, find me an example of an animal in nature that would do a time estimation kind of task. And it was true that I realized when we wrote the paper, the 2020 paper, and I wanted to find an example for the introduction, for the first line of introduction, I was really struggling to find what is the right example. It's actually extremely rare, even for human, extremely rare to have like a pure time estimation experiment.
But that fits exactly with your modern conception.
Exactly, and that fits a lot with what Bergson was saying. So it's that was kind of like the, I needed this kind of guy actually assuming, all the way in that the experience of time is something different than measuring time. And that's what we're doing in neuroscience, is that we take the experience of time of an animal and we would like him to measure and say long, short. And that's...
We're like, I'm measuring it, you measure it too.
Exactly.
Yeah.
Exactly. So and that's great. I think it's great also if you have actually, if there's ideas that you push. And what I found really nice is that, is how the animals were telling us, you guys, this is wrong. And actually, when I talk to people, I go visit labs, a lot of people that are doing this kind of experiment, they tell me, oh, we've seen it too. And so what's very interesting is why nobody speak about it, And that also that you have to do an experiment in which, okay, now that we see that the animals are moving during time experiment, you have to think about a way in which the animal is not moving. Because otherwise you won't be able to do a Nature Neuroscience paper that would be purely about cognitive things, because movement is not the right stuff. It's nuts.
It is. I appreciate that more and more, how arbitrary it is to try to untether our behavior from our minds, because it's just a continuous cycle, analog, continuous, and it's never divorced. Although, even like John Krakauer would argue, like, well, actually we do have these internal representations that are divorced, and that's, pretty special. But even that, it's maybe, I don't know where the line is. He doesn't either. No one does, right? Or whether, because even if you have this internal representation, it is still continuously connected with another layer, with another layer, with another layer, and there's out into the environment, embodied and in the environment. So I know I'm preaching to the choir here. We're not going to get into a free will debate, but as you were talking about looking at a clock and measuring, it reminded me of the Libet experiments, right? Where you're looking at a clock and then you note where the clock is when you volitionally, whenever you want to, like tap your finger, and then you note it. And the famous experiment, and there's been a lot to debunk these things, is that your brain reads out what you're going to do before you know you're going to do it, before you report that you have subjective awareness that you're going to do it. Therefore, we have no free will. And so there's been a lot of reasons why that experimental setup is perhaps not the best, has holes in it. But is there a road into free will with your conception now of?
Oh yeah, no,
time?
but well. Remember the translation, the title of the first book of Bergson in French is called Essai sur les données immédiates de la conscience, an essay about the immediate data on consciousness. But it was translated in English as Time and Free Will. That's the title of the book. And actually, if you read the book, so the translation is not great, but it's okay.
So you should learn French and read it in French.
You know what's crazy is that now that I'm talking to philosophers, and I've been talking recently to Japanese philosophers, people that study Bergson, they speak French. And I found that so amazing that, you know, like philosopher that studies German philosopher, they actually learn German. And that's a very different world than our world. But
yes.
So the book is actually, if you look at the book, the foreword of Bergson is that actually the problem is want to attack with this question of time is the problem of free will, you would call or freedom. His point is that the problem of the free will is just like a very badly framed problem due to a sort of mechanistic kind of like approach. He basically says, and that's once you've understood durée, the problem of free will totally vanishes.
Oh, how's that?
If every moment is new, okay, so at every moment of our life is a new moment. So
then we're not bound.
We're not bound to anything. It's like we're actually creating ourselves. How could, you know, at each moment. So that's it. There is no.
Yeah. This could really make us go another few hours.
Yeah, no, it's very interesting on how he says, the problem of the way we think about free will is because we're thinking retrospectively. Okay. We see something that happened, and then after it's been done, we think, oh yeah, I can understand why David decided to jump out of the rock at 10 meters high, you know. But actually, when I went, you know, to do that jump 10 meters high in the sea, I'm like hesitating, but nobody knows what I'm going to do because this is a new moment for my life. Even me, I have no mental, kind of like internal model of this because I'm a new person doing something new. So actually this new thing, it's going to define me. If I jump it, I'll be like, oh, well, yeah, I did it. And I'll be a new person. If I don't do it, I'll go down the rock. My son will be looking at me and say, hey, Dad, you didn't jump. And so you see what I mean? But so retrospectively, of course, we can explain things. But the question is that when you do something entirely new, how can you explain something that never happened?
But then, okay, so it's a liberating idea then that we're constantly, everything is new in every moment, every passing moment.
Exactly, it's very liberating.
But then why do I have the same stupid habits that I've had for a long time? Why is it so hard to change things?
Yeah.
And why am I so predictable in so many respects if I'm creating myself anew in every instance?
Yeah, because we have this fight between, so it's a sort of balance between surviving, in which we need to somehow take advantage of regularities that are beneficial to us.
Not jump off the rock.
Yeah, for instance, if this is to, you know, it can be advantageous in some cases.
Right.
If this is to impress somebody, like you want to impress your son. So we're gonna get, you know, we'll be able to, take advantage of some kind of like regularities to be able to live, find food, striving in the world. So there is this kind of like competition between some kind of like habit in which we take advantage of the world for things, but also we're changing. At some point, the bad habit will break or not, but it will change anyway, or you'll get more and more frustrated with your bad habit. I'm also
Sure.
I think there's a word that Bergson uses that if I have free will, okay, I can understand why I need some kind of like determinism to take advantage of the regularities of the things that happens all the time that I cannot use. Okay, that cause and effect. If I have this free will, it's really important that I'm also able to take it. But if I was entirely determinist, why do I have this feeling of free will? I like this way. It's kind of
it's counterintuitive, and it uses the argument against free will for an argument for free will. If things are deterministic enough, I can actually make use of that. Yeah. I have to make us switch gears here because this podcast, although less and less so, is ostensibly about the natural and artificial intelligence and sciences. What does this mean for artificial intelligence? So, you know, a robot could just actually keep an internal Casio watch clock, right? Why would this conception or implementation or way to approach time make any difference for an artificial intelligence?
Well, I think it makes, so, you know, I'm not an expert in intelligent artificial.
But I wouldn't want my computer to subjectively become bored or to go faster sometimes and slower sometimes. I want it to be
constant. But that's the big difference, I think, and that's why I think people are interested in Bergson now, is because this durée is really something that is not in our computer or that is not in AI. Is that, like, you know, I don't know exactly how works the AI algorithm, but we can imagine that it's, you know, in the computers there's clocks that kind of like, you know, that
it has to be precise.
It has to be precise, and it passes time regularly, and one being, you know, is separated from the other one.
Mm-hmm.
And that's, you know, then you stop the computer, you turn it on again an hour later, and, you know, you can go back to where you were before. But that's exactly not how durée is actually the opposite of that. Durée is the fact that you cannot bin. It's this kind of like continuous merging that makes that if you stop doing something, you become impatient or uneasy, etc. But I don't think AI yet, you know, if you're interacting with ChatGPT and asking him question about French philosopher, and all of a sudden you stop asking, he's not going to tell you, hey, what's going on? I'm like, or even like shut down, or, you know, it's not built like that for the somehow from this kind of like accumulation and merging from the past to the present. Things are very discretized, I think, in this kind of like system. So I think this is what is kind of interesting. Is it's very, it's a very different. There's no time. Basically, time doesn't matter anymore in AI. No, there's no time. It's just sequence of things.
Dynamics matter, but time. So would you want an AI to have this same sort of Bergsonian durée? Like, would there be an advantage? I mean, there's obviously an advantage. No, there's not obviously an advantage for us. Actually, I was about to say. I don't think
if it's is it possible? Can we? I don't think we can do that. I think that's really.
It's dependent on being a living system. You think?
I would kind of like think so, but I'm not. I haven't really thought how you could somehow, because the idea is that we're constantly kind of like transforming ourselves. You would say, okay, an AI system is also constantly growing,
updating its weights,
updating.
Yeah,
but I don't feel like that would give. You wouldn't say that it's getting old, no? Or like, you know, like...
well, my computer's getting old right now. In a different way.
Yes, but you see what I mean? For an AI that is like, okay, now it's... Or you wouldn't... Yeah, you... How would you... So how could you include impatience? Like a true impatience? Because the true impatience doesn't have to be played repetitively. You know, because I'm impatient now I go out, I take my car, the red light is too long. But it's going to be different if I do it tomorrow. So it doesn't have to be an impatient that is replayed all the time. It's got to be new every time. And that's not possible. We want the AI system, it's got to be very regular. When I ask him, what's the birth date of Bergson, he's going to give me the birth date each time. But if you keep asking me, maybe maybe I'll be bothered by your question and I'll tell you something stupid. I don't know if this can come into an AI. I don't think they're designed for that.
But so one of the advantages for us having this sense is, let's say the hawk is coming down on the mouse and the mouse needs to hurry the hell up and get in the hole. And so time is going to go very slowly because it needs to move very fast, right? Mm-hmm. And that its durée in that moment is changed for it subjectively. So our timing, our sense of timing is dependent on motions and the needs of our demands from the environment and to survive, etc. But maybe, take the example of self-driving car, right? You would want it to, I don't know, if the boulder is, well, let's say David has jumped off a rock 10 meters high thinking that the highway was actually the sea, and you detect David falling through the air, and you don't want to contribute to his demise by hitting him with the car also, right? You'd want your car to be able to slow down, but I don't think you would actually need durée to do that. You could still just use clock time if you're the car. Yeah. Are we just constrained because we don't have an internal clock? We can't use clock time. We have to use this durée. Is that one way to phrase it?
Yeah, well, durée is making itself in us whatever we do. It's imposed to us. We're changing right now, there's we're growing some reflection about our discussion, and then so it's like we cannot escape it. It's kind of a force of change, in a sense. We're not going to stay immobile, or something is going to happen with time for sure for us, which I don't think is the case for an AI. Like if we stop it now, it's not going to say, "Hey guys, take care of me" or whatever. No, because we're we have those metabolic needs that we need to, so we're in perpetual kind of like disequilibrium. And so time is actually important for us.
And is it in that sense that Bergson also conceives of time essentially as a force upon us?
Exactly. It's like it's going to do something on you.
So
it's an active thing. And that's actually why actually, and that's what you see a lot. And that's what's great is actually when you do those time experiments where you ask animal estimate, you're constantly surprised at why do the animal always go too early? Because time is acting on us. And so actually for the small kind of like story with this time experiment we designed with Pavel, at the beginning, we wanted the rats to wait 10 seconds.
Okay.
Because we thought like this, we would get like a lot of good units, like a good stable chunk of units for 10 seconds. And then we were really pissed because the rats, when they started doing this task, they were like 9.5.
You're too
all
impatient.
The time. Yeah. So we said, okay, let's move down to 9. And then they moved down immediately 8.5.
Oh.
And so we kept moving down. And then at some point we realized that they were like, they would just want, So I think, and this is true in like, if you look a lot of different papers, like the work of Ben Seolievsky, if you look at the data, the animals, they really struggle to wait. And in that sense, that's where you can see that they're acted by time. They want their reward as soon as possible. Time is important for us, for them and for us too.
So then just to wrap up our little AI segment here. So not only can you not imagine why AI engineers would want to figure out how to implement or program in this sense, but you can't imagine that it's possible in a machine. It has to be a living being.
It has to be a living being for which time matters.
For which time matters. Are there living beings for which time doesn't matter?
No. All living beings, I guess maybe for plants it's a little bit different.
No.
You could think
time because they're having to create themselves.
Well, but they're just like in the place in which actually they get their food for free. They don't
No, they have to, like, their roots have to go down. They have to bend toward the sun. They still have to, like, configure. But that's a plant cognition conversation.
Yeah. But you see what I mean? I guess what you would have to design is something like, if you were putting an AI under pressure, then maybe I shouldn't say that. We don't want to go there. Please.
No. And also, I don't want an AI to be impatient with me. Come on, hurry up. Ask a better question. Come on.
Yeah, exactly. So that would be the reason why. It's like, that is time matters for AI? No, it doesn't. No. But for us, time matters, Mm-hmm.
Another thing you mentioned in your paper is again, I see it as a sort of recent trend among people like you and more increasingly me, of saying, doing this. Okay, from my perspective, there's this kind of recent rah-rah science needs humanities sort of movement. And I always kind of question that, thinking, well, does it really? Or does a certain segment of scientists need humanities, and those can be the people who connect it? But so that was kind of thrown in there also. And I'm curious what your take is. Like, why are we hearing this more and more, that the science need humanities, and how you got from this idea that time is not in the brain to connect to science needs humanities is important. So
the idea, if we stay on the time topics, is that impatience, so this way we are changing in time all the time, because it's changing all the time, it's basically unreachable by science. We're always going to be a little bit behind, right. We're going to lag behind all the time in this description. So we'll do a description of the living that is actually a mechanical description,
because it's the best approximation we can do in the given moment.
Exactly.
Yeah.
Exactly. So there will always be a sort of like gap between the mechanical kind of like stuff and the real changing creative process that is life. And so then if there is a gap, then there might be other way, to address this. So for instance, you can learn a lot about perception with visual artists. Okay, because they're gonna, do you some experiments, and you won't be able to actually. They won't, there's no point of putting electrodes while you're watching stuff or etc. No, it's just gonna be it's a different kind of experience, because it's just focusing on the experience itself. Okay, and because it's a new experience, to do science, you need to repeat an experience. Let's say it like this, very simple. If you want to do a science something, you need to repeat. How would you repeat somebody watching a piece of art? It would be it won't be the same. Once you've seen it, the second time will be, by definition, different. It will not be the same. So you won't be able to do science. Actually, I think it's an under kind of like appreciated phenomenon in neuroscience. We try to have the animal doing the same trial over and over and over, right. And they don't actually. It's not true. It's not, we would like them to behave like robots, but they don't. So my point with the art stuff is that there will be a limit in which, because of this novelty stuff. And so then we can just talk about it in literature. Literature will give you a sense of what's happening in the mind of an artist creating, or a character watching a piece of art. That will be much more as valuable in form of knowledge of humanity than knowing what's going on in his brain.
But that's okay. So that's separate from what I think of as science, which is where you want to be able to reliably reproduce results. So that's its own thing. That's not science using humanities. It's almost not science, right? It's just a different description, a different story of experience.
Exactly. And it's a valuable one.
Okay.
It's not sure that it's failing more than science, in the sense that, science is great and it's approximating a lot of things. There's no question about the benefit of science and scientists. But it's because it's like kind of always lagging behind. Then let's not discard, other form of like approach to reality. Arts is one of them. Literature is one of them.
But this is different than bringing, I'll just say humanities to encompass all of them, bringing humanities into the science. It sounds more like appreciating the humanities as a different perspective.
You're right. Okay. So that was kind of my original point. Now, the only maybe little twitch that I could say is that, well, for instance, so there is often like the tendency to think that neuroscience is going to help philosophy. I feel like my re-encounter with Bergson was the opposite. It's like basically Bergson for me, but it's still a debate, but for me, he's kind of like solving a problem in science.
Well, it changed your perspective. It changed the way that you approach the problem, right?
Yeah. Well, or you can say, there's an entire committee that is struggling with trying to have rats doing time estimation experiment. And there's a guy that say, hey, maybe it's because you're confusing time and space. That's cool, And I think that's great. I think, it's interesting. It's not to think that every experiment is a good one. Maybe there's experiments that are just, another, I think your guest, Paul Sisek was there.
Paul Sisek,
yeah. He has a very nice paper, I think, or at some point where it's the introduction of one of his papers saying that, the toughest part in science is actually to find the right question. And I think it's really true. And it's sometimes we ask questions that are like some kind of like, very quick, superficial psychology. And then we apply it to animals and then it fails. I think that's the case. So in my case with Bergson, I felt like, I think people should take, should read him and actually take in account his, and maybe it's redirect science so much. So this was something else with what I liked a lot with Bergson is that is actually all his philosophical work is very tight to science.
See, okay, that's what I was about to say is I have my own internal dialogue sometimes like, is what I'm interested really philosophy or am I interested in science? And really what I'm interested in is just knowing stuff and I'm curious about stuff. But I think it's easy to, once you start sort of opening that door to philosophy, then it's easy to kind of get hung up because you get immediately into the debates and the semantics around the concepts and then you can just get lost there. So having it always having like your perspective where you had already this sort of scientific data set and viewpoint and questions, and then you revisited, in your case, Bergson, who you revisited in light of your specific set of questions and problems. And that was effective. And that's where philosophy can be effective, I think. Because, everyone says, philosophy needs to be like the humanities. People need to read philosophy, but you can't just go read philosophy. You have to go with your set of problems.
I think you have to interact. I think the key here is to interact with people when you do. The risk is sometimes I feel like, it's a little bit too much closed society,
Philosophy?
Well, maybe both philosophy and neuroscience, they tend maybe to be a little bit too, in their thing. And I think the mix is great. And it's what is very interesting is that Bergson was actually saying philosophy should be much more like science. And despite the fact that a lot of scientists were really pissed at him and were calling him really kind of like a rubbish, but he had this idea that what was lacking philosophy was the precision of science. And I think
that's funny because he got flack because he's very fond of using metaphors, right? And that's
exactly so because he's not a scientist,
right?
But he was trying to find actually good metaphor, and I think his metaphors are really sometimes it's really not. I mean, I love reading him. He's really it's very precise, very sharp.
Well, that's how we think is metaphors, right? George Lakoff, yeah.
Yes.
Yeah. What was it? Oh, yeah. I had this thought before we spoke. I was walking my dog and I was thinking about philosophy and science. And I remembered a recent conversation that we were having in my lab, actually. And the topic of whether pineapple is good on pizza came up. And of course, we all had our opinions on this, and we were sort of debating it. And then one of my colleagues, Mark, said, I don't understand why people are so adamant about their opinions about this stuff. And I thought, that's kind of like the way I feel about scientists and their opinions of philosophy. Like, why do you have to have an opinion on whether someone is interested in and uses philosophical inquiry to aid their own science, right? Like, you think it's useless. Other people find it useful. Who cares if there's pineapple on the pizza? The person eating the pizza likes the pineapple. There you go. There's a metaphor. There's an analogy.
That's a nice one. But do you really think that people think that philosophy is useless in neuroscience?
Oh, of course. Like, there's tons of historical examples of scientists talking about how useless philosophy is.
But that big names. But I feel my impression, I was extremely surprised by each time I gave a talk about this stuff, like how people were really engaging. I feel like people are actually hungry for doing meaningful stuff, and if you do an experiment and you wonder, why does it take you so long to train your rats? Well, it's kind of cool also to have like this perspective of like philosophy of people also that think about science. I think it's, and I feel people are hungry about that and students a lot. And I think that's really great. That's positive.
Yeah. David, I've hopefully I have not taken you over your personal durée, but I've taken you over clock time. So I've
a little bit, but it's okay.
Yeah, okay. My final question is, pineapple on pizza, yay or nay?
No.
Okay, spoken like a true
Sorry.
French person. But you're okay with other people having pineapple on pizza, right?
Totally.
Okay. All right. Thank you for your durée.
Well, thanks, Paul. It was really fun.
Brain Inspired is powered by The Transmitter, an online publication that aims to deliver useful information, insights, and tools to build bridges across neuroscience and advance research. Visit thetransmitter.org to explore the latest neuroscience news and perspectives written by journalists and scientists. If you value Brain Inspired, support it through Patreon to access full-length episodes, join our Discord community, and even influence who I invite to the podcast. Go to braininspired.co to learn more. The music you're hearing is Little Wing, performed by Kyle Donovan. Thank you for your support. See you next time.